Section 2.1 is increasing, decreasing, and piecewise defined functions. The first thing I'm going to talk about is increasing and decreasing functions. I've got the first example written on the paper here. They're just going to ask you, where is the graph increasing and where is the graph decreasing? Okay. Make sure you read your graph from left to right. So if we're looking at this graph from the left, see how it is falling left to right. Well, that's where your graph is decreasing. So my graph is decreasing from here to here, and you describe where your graph is increasing and decreasing by using your x values. Okay, so notice that this graph continues on. So starting from negative infinity until we get to this point right here where our x value is -2, it's decreasing. So I'm going to start by writing out decreasing. And it's going from negative infinity to -2. I know that there's more spots on this graph where it's decreasing, so I'm going to just put a union sign to connect the two intervals together. And if you notice right here, it is also falling from left to right, from this point to this point. Again, use x values. So my x value is 0 here, and my x value is 2 here. So from 0 to 2, it's also decreasing. And normally in textbooks, you'll see that they always use open parentheses when describing where it's increasing and decreasing, because at this particular point, it's not increasing, it's not decreasing, so I don't want to include it. But in some places it is, they do use the brackets, so it's all right, but normally we use parentheses. Okay, and you can also see that it's increasing from -2 to 0. And it's increasing from 2 to infinity. So just make sure you use x values to describe where it's increasing and decreasing. They're also going to talk about the local maxes and the local mins. So I'm going to draw another graph here so we can talk about what the local max and the local min are. And I've got the points -3, 0, -2, 2, (1, -2, 2, 1, and 3, 0. Okay, and local maxes and mins are just that, they're local. So you might have more than one local max or more than one local min. It's a high point or a low point in that graph. So you can see the hills are where you're going to have local maxes. The valleys are going to be where you have local mins. You never use endpoints to describe your local maxes or local mins because you don't know what's happening after that point on the graph. Also, if your graph does go to positive infinity or negative infinity, those would not be included in local maxes and mins. So it's strictly where you see hills for your local maxes and where you see valleys for your local mins. And you're going to use y values to describe these. Okay, so my local maxes, and there are two in this one since there's two hills. We've got one at the y value of 2, and we've got another one at the y value of 1. And we do see a local min. The y value here is -2. And sometimes you might not see a hill or you might not see a valley on the graph. Then they just wouldn't have a local max or a local min depending on what you see in the graph. Okay, and finally, the last thing in this section are piecewise defined functions. Let me just write out an example of one. F of x equals, and they've got 3 different choices for this one. So x squared if x is less than 0, 2 if x is equal to 0, and 2x plus 1 if x is greater than 0. Okay, so that is an example of a piecewise defined function. You've got different pieces to your equation, okay? They'll ask you maybe certain values off of your piecewise defined function. So I'm just going to do a couple of those first. Part A, I've got f of -2. Okay, well this is the value that they want you to plug in, -2. -2 is your x value. Well, you don't go and plug it into all of them. Notice this tells you the domain for each of the pieces. So you want to plug the -2 into whichever one the -2 belongs to. So is -2 less than 0? Is -2 equal to 0? Is -2 greater than 0? Well, of course it's less than 0. So we're going to use the top one for this first one. So we'll plug -2 in for x. And we get 4. Okay, and we'll just try a couple more. So part B, they gave me f of 0. Okay, and again, you ask yourself, where does the 0 fit? Well, of course, this middle one says x is equal to 0. That's the only place where 0 belongs. So we're going to plug it into this middle one. Notice there's no variable in this one. Well, then it's just that answer, 2. And part C, they gave me f of 2. Okay, well, of course, that fits into the last one. 2 is greater than 0, so we're going to plug it into this last one here. So we'll plug 2 in for x, so 2 times 2 plus 1 gives me 5. Okay, it just happened that I put them in order, but just look to see what value they're asking you to plug in and check to see where it fits in the domain to pick which piece you plug it into. Okay, they're also going to ask you to graph some of these. Well, what I usually do, there are different ways, but what I usually do is I make a separate t-table for each of the pieces so I can keep track of where it's supposed to start and where it's supposed to end. So I'm just going to make an XY table for each of the pieces. Okay, so this first one I'll let be the x squared part. The second one is the 2, and this third part is the 2x plus 1. Okay, and normally you get to pick whatever you want for your x values, but you have to be a little bit careful here. Remember, this is going to tell you the domain. So for this first piece, we only want x's that are less than 0. Okay, well, I like to start with the endpoint that they gave me because I want to make sure I graph the complete thing. So I'm going to start with the 0. But notice there was no equal sign, so the 0 is not included. Well, I'm going to mark that next to the 0 here, an NI, because that way when I graph it, I'll just use an open circle because it's not included. Okay, but then I want to pick values that are less than 0. So I'm going to pick a couple more values that are less than 0. And that should do it. I could have kept picking values, so I like to draw a little arrow here, so when I graph it, I remember that I'm going to need an arrow on the graph, because I could have kept picking values that were less. And to find the y, we just plug in the x value into our piece here and see what our y value is. So 0 squared is 0. Negative 1 squared is a positive 1. And negative 2 squared is a positive 4. And we'll do that for each of these graphs, or each of these tables. Okay, so for the second table, well, we can only have x equal to 0. That's easy. So we only have one choice for x, and when you plug it in, there's nothing to plug it into, so the answer is just 2. Okay, so that table's done. Looking at our third table, well, we want values that are greater than 0 now. Again, I'm going to put 0 here. It's not included because there wasn't an equal sign with it, so I'm going to put an NI there to remind myself, don't put a closed circle. And then I want values bigger than 0, so I'm going to pick 1, 2, and it could also keep going. So I'm going to draw an arrow. And we'll just plug everything in. So plug 0 in, we get 1. Plug 1 in, we get 3. And plug 2 in, and we get 5. And we're ready to graph it. Okay, so I'm just going to move this paper up a little bit. And they all three tables get put on the same graph. Do not connect tables. They might naturally connect on their own, but you never connect the tables, but you connect the points inside a table. Okay, so let's go ahead and graph this first table. So the first point, 0, 0, it's not included, so make sure you just put an open circle at 0, 0. And then the rest of these are closed, so negative 1, 1. And negative 2, 4. Okay, and you want to connect those points. And this is where you remind yourself you could have kept picking values that were smaller, so you can continue this graph. Okay, the middle table, well, I've got just 1 point, 0, 2. And that's it for that table. And then our last table, we've got 0, 1. We reminded ourselves that that has to be an open circle. And then we've got the point 1, 3. And the point 2, 5. Okay, and keep track of which points were in that table. Those are the only ones you want to connect. I again drew an arrow to remind myself that this is going to keep going. And you've got your graph. Okay, so go ahead and try out the homework, and if you have any questions, just let me know.